Welcome to today's explainer. Look, if you're involved in manufacturing or enterprise logistics, you already know the deal. Global supply chains are facing just unprecedented volatility right now. We're dealing with geopolitical shifts, wild market fluctuations, and these endless complexities that are simply moving way too fast for human planners. And frankly, they're moving too fast for our legacy software too. So today we're going to focus on a massive revolution happening right now, particularly within Thai supply chains. We're talking about the shift to Enterprise Agentic ASCP, or Advanced Supply Chain Planning. We'll be looking at how fixing those broken legacy systems with a structured, intelligent ecosystem of AI agents is completely transforming the way businesses operate.
Okay, let's dive into this. Here is our roadmap for today. 1. The legacy supply chain crisis. 2. The agentic AI solution. 3. The three-layer AI architecture. 4. AI in the Thai context. 5. A garment factory case study. And finally, 6. A four-phase implementation roadmap.
Section 1. Legacy Supply Chain Crisis. Seriously, I want you to think about this question. Why on earth are we still waiting 24 hours for a supply chain plan? In traditional systems, like older versions of Oracle ASCP, planning is processed in these massive, heavy batches. You essentially hit run at the end of the workday, and then you wait. You wait for this colossal SQL calculation to churn overnight just so you can get a plan the next morning. But in the real world, a critical machine breaks down or major order gets canceled in seconds. Waiting a full day to adapt while the global market shifts in minutes, that's a critical vulnerability.
And that really highlights the core difference. Legacy systems are monolithic. They're rigid. They crunch massive amounts of historical data in 6 to 24-hour batches, and if a disruption happens, the whole thing bottlenecks. But the new paradigm? Agentic ASCP. This is all about continuous replanning. It's totally event-driven. Specialized AI agents instantly negotiate and recalculate only the specific parts of the chain that were affected. It's real-time, it's distributed, and it is incredibly agile. Moving on to Section 2, the Agentic AI solution. Now, you can't just throw AI at an old system. The sources refer to a major challenge here as the messy car problem. Imagine taking random high-performance sports car parts and just bolting them onto an old, rusty chassis without a proper blueprint. Eventually, the whole car falls apart, right? Well, when developers try to bolt raw, unstructured large language models directly onto legacy ERPs, it causes total data chaos. Unstructured AI tends to hallucinate. Maybe it forgets to close a bracket in a JSON file, or it outputs a random string of text when your database strictly requires a number. This breaks your downstream applications, it crashes Excel reports, and it absolutely destroys data integrity. So how do we fix it? Actually, we don't use a single massive AI brain. We use hierarchical multi-agent systems, or HMAS. Think of this as a highly structured ecosystem. You deploy specialized AI agents. So you got one for inventory, one for procurement, one for production, all acting as individual digital planners. And they don't just guess, they continuously negotiate with each other in real time to find the optimal business balance. Say procurement wants to buy materials in bulk to save a few bucks, but finance flags a cash flow issue. These agents negotiate a compromise instantly, without human intervention. Section 3, three-layer AI architecture. Now, what's really interesting about this is how these modern AI frameworks map perfectly to a traditional corporate hierarchy. At the very top, we have LangGraph. Think of this as your director or your project manager. It routes the workflow and decides exactly which agent gets which task. Next is Pydantic AI. That's your QA leader. Its entire job is type safety, forcing the AI to output perfect structured data. If the AI makes a mistake, Pydantic AI literally forces it to self-correct before that bad data ever reaches your ERP. And finally, at the bottom, we have MCP, functioning exactly like your IT department. And let me tell you, that IT department function, MCP, is revolutionary. The Model Context Protocol is essentially the USB-C for AI. Before MCP, you had to write all this custom, super fragile code just to get your AI to talk to Oracle or SAP. MCP is an open standard that allows your AI agents to securely discover, read, and write data directly to legacy ERPs without causing a total meltdown. It's the vital connector that gives your AI the tools to actually execute plans, rather than just generating text about them. Section 4, AI in the Thai context.
Look, technology doesn't exist in a vacuum, right? It exists in a culture. And in Thailand, workplace culture heavily emphasizes hierarchy and respect, which is encapsulated in the concept of krang jai. You can't just deploy a flat swarm of AI agents that casually bypass human managers. It just wouldn't work. The sources highlight that the AI's logic must actually be programmed to mirror this culture. We use an escalation logic based on impact severity. If a machine breaks down, the worker agent tries to solve it first. But if the impact is too high, it doesn't just bypass the supervisor. Instead, it generates a formal executive summary and escalates it up the proper chain of command, ensuring human supervisors remain respected and totally in control. On top of that cultural alignment, these agents must strictly adhere to the Thailand E-Government Interoperability Framework, or THE-GIF. This means the AI has to communicate using standard JSON or XML over RESTful APIs, it has to secure everything with OAuth 2.0, and crucially, it must use UTF-8 encoding. Why does that matter? Well, if the AI misreads Thai characters, it could completely botch a critical e-tax submission or a major government procurement document. So compliance here isn't just an optional add-on. It's hard-coded directly into the agent's behavior.
Section 5. Case Study. Garment Factory.
Let's look at some real-world proof. The garment industry is incredibly complex, right? But by deploying a specialized dyeing agent powered by neural networks, one manufacturing operation achieved a dramatic 60% reduction in dyeing errors. Traditional dyeing is super tricky because colors physically shift from when the fabric is wet to when it's fully dry. But this AI agent analyzes vast amounts of historical data and predicts that wet to dry shift perfectly, saving an immense amount of time and wasted chemicals. And then there's this number, a massive 35% reduction in total inventory. How did they pull that off? Through continuous multi-plant load balancing. Instead of each of the 4 different plants hoarding their own safety stock just in case, a global orchestrator agent constantly monitors all 4 facilities. So if plant 1 runs short on black thread, the agent instantly checks plants 2, 3, and 4 and automatically routes an internal stock transfer right through the ERP. No phone calls, no panic. And the return on investment just keeps going across the board. The system optimized their shipping routes to achieve a 15% reduction in transport costs. Furthermore, they deployed a specialized computer vision cutting agent. It analyzes the absolute best way to cut patterns from raw fabric, which led to another 15% reduction in physical fabric scrap. This whole system isn't just about software speed. It's about measurable, bottom-line, physical efficiency. Finally, Section 6, 4-phase implementation roadmap. Now, if you're thinking about doing this, the sources outline a very pragmatic 4-phase rollout. You absolutely do not want to do this all at once. Phase 1, the first 3 months, is all about infrastructure and building a minimum viable product. You set up Agentic AI and LangGraph just to prove the AI can output perfect data without breaking anything. Phase 2 introduces that agent negotiation we talked about. Give them conflicting goals, sales wants high stock, finance wants low stock, and let them find the balance. Phase 3 integrates the wider ecosystem, bringing in departments like QA and accounting. And finally, Phase 4, usually after a year, is autonomous optimization, where the system is adapting to market disruptions almost entirely on its own. So, the crucial point here is security. You are literally giving AI the keys to your ERP system. You must implement a zero-trust architecture. You have to treat every single AI agent exactly like you would a brand new, completely unproven human employee. They get strict, role-based access control. They only get access to the specific data they need for their job. You maintain unalterable audit trails, and you set firm daily budget limits on what they're allowed to authorize. Trust is earned, not freely given. We've seen how Agentic ASCP can take a slow, reactive legacy system and transform it into a real-time, proactive ecosystem. By using the right frameworks like Agentic AI and MCP, and by deeply respecting cultural workflows like krang jai, the results are pretty undeniable. So I'll leave you with this final thought to ponder. As this technology rapidly moves from just predicting things to fully executing them, is your organization ready to hire its first autonomous digital planner? Thanks so much for joining me on this explainer, and I'll catch you next time.